Hi guys, another day, another lesson. I wanted to congratulate you guys yet again. I just graded your exit tickets and you all got meets on your exit ticket from yesterday. So something in these videos are working, so we're just gonna keep it up because I'm pretty impressed with you guys. Let's hope that it stays this way. Today we're going to be learning a new skill, creating a histogram and really describing the shape of a histogram. It's similar to a dot plot, but it's used when we have a lot more values or we're talking about a spread of data. Today, in the first example, we're talking about boys and girls basketball teams, and they want to raise money to help buy new uniforms. They decided to sell baseball caps with the school logo on the front to family members and other interested fans. To obtain the correct size, students had to measure the head circumference, distance around the head, of the adults who wanted to order a cap. The following data set represents the head circumferences in millimeters of the adults. Data set is right here. The caps come in all different sizes: extra small, small, medium, large, extra large, and extra, extra large. Each cap size covers an interval of head circumferences. The cap manufacturer gave students the table below that shows the interval of head circumferences for each cap size. The interval 510 through less than 530 represents head circumferences from 510 millimeters to 530, but not including 530. So let me break this down for you. So we have our frequency table that we were working on yesterday, but we have this extra column that's now been added in, and it's talking about intervals. When you see an interval, you're taking this number, and this number can be included. So 510 can be included, but it says through less than 530, okay? So this is really like saying from 510 to 529. The next one's like saying 530 through 549. 550 through 569. So you're not including whatever number is here. That's what's really important in this. It's through this amount, and I'm including every number there. So I'm going to give you an example. Extra small, 510 through 529. So I'm going to look, and luckily this data set has already been ordered for you from least to greatest. They were super nice on this one. So I see 513, 529. So that's 2 tally marks and a frequency of 2. Sorry, that was a little messy because I'm trying to look at it through my phone. 2 for this section. All right, for extra small, I have 530 through 549, not including 550. So I'm going to count that out. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. My frequency is 8. Okay, count out the rest of them and come on back. Go ahead and pause the video now. All right, double check your work. Make sure that it looks like mine. And now we're going to move on to the exercises, which means that we're going to look at this data and decide what it means. What size cap would someone with a head circumference of 570 millimeters need? So I need to look for 570 millimeters. Now I see two 570 millimeters, but remember, this size does not include 570. This includes 569. So I need to go to the next one, which would mean that they would need a large. Yeah, they would need a large. Large size cap. Okay. Complete the tally and frequency columns in the table. Okay, we already did that. I was jumping the gun a little bit. What head circumference would you use to describe the center of the data? Center of the data. For this one, we are talking about median still. If you don't remember what median is, look at lesson number 2, but there's also a little helpful thing on the back board if you're really getting stuck. I'm going to do that with you. When you're doing center of the data for median, you need the data to be set from least to greatest. And we're crossing one least one greatest off at a time. And I'm moving inwards until I get my final center. So I'm gonna work that, going back and forth until I get it. And now I'm stuck with two numbers. Now, on the backboard, it says that if you have two numbers left, you need to add them together and divide by the number of numbers you have. So this would be like adding 563 plus 563 and then dividing it by 2. But some of you realize that if it's the same number, that you don't need to divide it by 2. That's your answer. So my median is 563. Millimeters. Now you're going to describe any patterns that you observe in the frequency column. So we're describing patterns. So what we're kind of noticing that I want you to notice is kind of like how the data shape is going to look if we were to put it into a histogram. And a histogram is just kind of like a bar graph, but it's using these intervals. Like a bar graph, but using these intervals. So what I'm noticing is that it starts off really small, comes up to a point, and then it kind of comes back down again. So I'm noticing that it starts small, increases to 15, and then goes back down. Goes back down. Now we're going to be looking at how to do a histogram. Now there's a bunch of steps right here to show you how to do that histogram. Now they've already set up a basic histogram graph for you. They were super nice. It looks like a typical bar graph, but you're going to notice that the left-hand side is normally always going to be your frequency. Always. Your bottom is going to be whatever you are doing in your intervals. You're going to notice that they look identical to your intervals, and then there's our title. Then you have this new thing right here. This little kind of like up and down check mark shows that it starts at 0, 0 here, but there's a gap between 0 and 510. So this is showing that it's not including every single number between 0 to 510. That's like your signal of there's a gap. When you do frequency and histograms, you need to have this because or else it's not going to make sense. You don't have an appropriate scale. So we need this so that we know. They've already graphed our frequency for 510 to 529, 530 to 549. Now we need to look back at our data and we need to graph the other ones. So when I'm graphing 550 to 569, I have 15 in my frequency. So I'm going to go all the way up to 15. Okay. My next one is 9. My next one is 4. And my last one is 5. All right, your histogram should look something like this. So again, just like we noticed for the patterns, we start small, we come up to 15, and then we dip back off. Okay, yours should look just like this. Now we're gonna be asked to describe the data. This is very important in terms of that you're going to be doing for this for the rest of your module, describing what the data looks like, including the shape, okay? And we'll talk about shape in a second. So the first thing it says, complete the histogram, drawing the bars of the frequency. Done. Number 6, based on the histogram, describe the center of the head circumference. Now we know what the actual center was, 563, but say we didn't have all the numbers. Say we just wanted to look at this and we wanted to describe what would be the center. Okay, I would say based on this, my center would be somewhere in here. All right, looks pretty much in the middle based on the data. Well, it looks like it's about halfway between 550 and 570. That's about 560 millimeters. And if I think about after actually doing the median, I'm not too far off. I really am not. So it's a really good estimate when I'm just looking at the histogram. It also helps that I've already done the median. Number 7 says, how would the histogram change if you added head circumferences of 551 millimeters and 569 to the data set? What would happen to it? Well, if I added one for 551 and 569, I'm only adding it to this interval because 551 and 569 falls within here. So my data for this size cap would go up to 17. So the bar for 550 to less than 570 would go up by 2. Simple as that. It would go from 15 to 17. Number 8, because the 40 head circumference values were given, you could have constructed a dot plot to display the head circumference data. What information is lost when a histogram is used to interpret data distribution instead of a dot plot? So this is a big thing, is deciding whether you're going to use a histogram or whether you're going to use a dot plot. Histograms are used with generally more than 25 points of data. The reason being is that it's really hard to plot a lot of dots. It gets very messy. It's very hard to keep track of. It's a lot of dots. That's kind of the value of histograms. It's very easy to plot it once you get a big number of data. But it says what information is lost when you go to a histogram. The information that's lost from going to a dot plot to this is that you are not able to see individual values. When we look at a dot plot, each dot is someone's value. When we look at a histogram, we just know that this many is within here. We can't see individual things. We can only see a cluster. Not able to see individual values. We're not. Suppose that there had been 200 head circumference measurements in the data set. Explain why you might prefer to summarize the data set using a histogram rather than a dot plot. Like I just talked about, it's too hard to plot 200 dots. Histogram makes that a lot easier. Now for the last part, we're going to be talking about shape of the data. And there is 3 more exercise 10, 11, and 12 left. I am just going to cover what are the different shapes. That's our main thing. So we're going to be looking at histogram of battery life. When we see this, we're looking at, if we have the center of the data, what does it look like? This data looks pretty equal on both sides. It goes up, it comes to a middle, and it comes right back down, kind of in a bell shape, okay? We call this shape symmetrical. Ooh, and I never remember how to spell symmetrical. Symmetrical, it's on another plate. Or symmetric. Oh, it's 2 M's, guys, 2 M's. Symmetric, okay? That's the shape. When it looks pretty even on both sides, now, again, it's not exact, but when it looks pretty even on both sides, that's symmetric. Now this one. So again, it looks like a bell. Okay? This one doesn't look like a bell. This one is skewed. But this one has a specific language. Now when we look at skewed data, we need to look at what area of the data is empty. And this can be really difficult to remember because it's the opposite. So whatever data is empty, so you notice how the right side of the data is empty over here? There's a lot of data on the left side. This is called skewed right. Because it's empty on the right, it is skewed right, meaning this set of the data is empty. Okay? So what would you call this one? What's the shape? Is it skewed, or is it symmetric, skewed left, or skewed right? Now, if you don't know what skewed left means based on skewed right being empty on the right, skewed left means that it's empty on the left. Skewed right, empty on the right. Okay? What is the shape of this? Go ahead and write it down now. What is the shape of number 12? Write it down now. All right, guys, we made it. This was a really long one, new skills that we were learning, so I needed to really take my time. You did not need to complete any of those questions for 10, 11, or 12. Just tell me whether they were skewed left or right. Get it checked over with me. Then you may grab your exit ticket. Then you may work on your homework. Please ask if you have any questions.